Hello all, welcome to the series of solutions. Today we have the question from JEE Advanced. And see the question, this is very large. The question is very large. Yes. And if you are thinking that the large question have a large solution, you are wrong. The question have a silly solution. You can do in your thought experiment. The question is very easy. And if you are stuck in the JEE Advanced world and cracking your nuts, you are so stupid. Because the question have nothing to understand, just a simple concept and the question is done. In let's see, don't see the solution if you have not read the question. There you can see the question, and here is the this is also provided in question. Okay, this diagram is also provided in question, and here you can see a block is falling from an inclined plane. The angle of inclination is theta. In the inclined plane, you have also done the projectile in inclined plane. But here is a twist. A cabinet is flowing from the inclined plane. Okay, a box is flowing from the inclined plane. And in the box, a ball is there. Someone is throwing the ball in alpha angle. Someone is throwing the ball in alpha angle with respect to the box. And the angle of inclination is theta. What have asked in question? They have asked in question the distance of PQ. What is the distance of PQ? This is the first question. And in the second question, they have asked that someone is standing here. Someone is standing here and watching the ball. He has seen that the vertical displacement of the ball is there, but the horizontal displacement of the ball is 0. And what I've asked? The velocity. The velocity when the ball is projected. When the ball is projected, what is the velocity? Okay. When the ball is projected, the velocity is u. You have seen that? But no. They have asked when the ball is not projected, when the ball in someone's hand, then what is the velocity of it? The box have a velocity in this direction because of the inclination. Here working g sine theta. G sine theta is acting here. G cos theta is acting here. For the g sine theta, the box have a velocity in this direction. Also the ball have the same velocity in this direction. And if we can talk about the time period, no, don't talk about the time. We can talk about the range of the projectile. The range of the projectile is mentioned in the question, the length of the box. The range of the projectile is mentioned, the range of the box. What is the range of the box is asked by them. And how we can calculate that? We can calculate that. Okay. The first question is, can we calculate that? Okay. We can calculate that. Now the question is how. You can see here, the ball have a initial velocity of u at alpha. This is the box. Here the ball have the velocity g cos theta, and this direction g sine theta. This have g sine theta. Okay. Now see that if the ball is going from here to here, the ball have g sine theta always. G sine theta is always acting on the ball. And G sine theta is always acting on the cabinet also. The box is also acted by G sine theta, and here is the twist. The relative acceleration for the box and the ball is always 0, because G sine theta minus G sine theta, the relative acceleration also 0. And for that we can say the ball is taking the time to be here to be here. The same time the ball is covering the vertical displacement. The vertical displacement, the concept of projectile. The ball, here is the ball projected with u velocity. Here is the velocity u cos theta. Here is the velocity u sin theta. Whenever the u sin theta is taking the ball to the vertical displacement, whenever the ball is taking to the vertical displacement, the same time is taken by the u cos theta to covering the range of the projectile. So the relative acceleration is 0, and the here is the velocity, here is the acceleration acting in this direction is g cos theta. In this direction the velocity of the ball is acting u sine alpha. This angle is alpha. This is the u. This is here acting the velocity is u sine alpha. So we can say that after some time the vertical displacement will be 0, and in that time the ball will cover this range PQ. So we can say 0 from the equation is equal to ut plus half at square. We can say 0 equal to the initial velocity is u sine alpha, and the velocity, the acceleration is acting opposite direction of the velocity, minus half g cos alpha, g cos theta t square. And if we can equate that, we can see here is a time t equal to 2u sine alpha by, one second, this should g cos theta, g cos theta. Here is the time period we have found. This is the time period. The ball is covering its range, and we can say that the ball is covering his range in the velocity of u cos alpha. Okay, so if we want to get the range PQ, we have to multiply that, the velocity and the time, 2u sine alpha by g cos theta into u cos alpha, and we are getting the range 2u square. Okay, 2 sine theta cos alpha, we can say u square sine 2 alpha by g cos theta. We have got the range. This is the range of the projectile, and also the distance of the PQ, and also the length of the box. We have got it, and now we are getting to the relative velocity. This problem. What is the velocity when the what is the first velocity? Without the initial velocity u, because someone is getting in outside and seeing that the movement when the initial velocity was not there, what is the velocity? They have asked us. If we are seeing the structure again, this is initial velocity, we don't need that. The ball is falling like that. The ball have a velocity. We have not drawn the box. The ball have a velocity v in this direction, because the ball is falling in this direction, the velocity should be in this direction. The velocity is v, and the angle is theta. Okay, the angle is also theta. Okay. The angle is also theta, and that moment he got the velocity u in this direction. this is the direction also theta. This, in this direction he got the velocity u, and the angle is with the alpha angle is with the this plane, with the inclined plane, and the inclined plane is with respect to the ground is theta. The angle of inclination is theta, and whenever someone is like watching that the horizontal displacement is 0, then we can say that here a horizontal displacement, the initial velocity in that horizontal displacement, in that horizon, is u cos theta plus alpha, we can say that. And here a velocity is working v cos theta. A two velocities are working in on the one particle. One is u cos theta plus alpha and v cos theta. If the two velocities are equal and they are in opposite direction, the particle should not have any horizontal displacement. So the case is true. V cos theta equal to u cos theta plus alpha, and we can find the velocity u cos theta plus alpha by v cos theta. You can get the solution. This is the solution. U cos theta plus alpha by cos theta is that solution. There is a solution. I hope so I have made you clear, and if I am able to that, this is my pleasure. Thank you. This is the solution. Please see it.